let's go ahead and take a look at another mixture problem done by a system of equations. This one, I think we'll look at this coin problem here. It involves quarters and nickels, and often when you have a mixture problem, I think I mentioned in the last video, you're going to go ahead and have either quantity equations where you compare the quantities of things that you have in some relationship, or you have value associated with them, or both in the system that you create. In this case, I think you're going to have a quantity and a value equation. Okay, so let's read the problem and then we'll come up with the equations. It says a bowl contains 3 fewer quarters than nickels. And so there's a relationship we could write an equation from in a minute. And then it also says here the total value of the coins is $2.25. And I think we could get another equation out of that. But let's first identify our unknowns. It says how many of the coins are quarters. So I think if we solve for the number of quarters and the number of nickels, we would more than answer that question. So let's let the n equal the number of nickels. Now that's the quantity, not the value. Of course, a nickel is worth 5 cents. And let's let Q equal the number of quarters. Okay, so in this first equation, it says there are 3 fewer quarters than nickels. So there are actually, quantity-wise, fewer quarters than there are nickels. So I want to be careful how I write my equation to relate those two. That really the number of nickels is greater than the quarters if there's 3 fewer quarters. So I would have to take Q and add 3 to it in order to have it equal nickels, because originally just Q itself, the number of quarters, is 3 less than the number of nickels. Therefore I have to go ahead and add 3. So I have one equation. Here's the second one. If it says the value of all the coins mixed together is $2.25, then I should be able to associate 5 cents times each of these nickels and 25 cents times Q number of quarters and come to a value. Instead of working in dollars, I'll work in cents and call it 225 cents. And so I'd have an equation that would look like this. I would have 5N plus 25Q is equal to 225 cents. And now I choose a method for solving. And I really like the fact that this top equation solved for a letter, so I'll just go ahead and put Q plus 3 in for N right here. So I'll get a new equation that will read 5 times Q plus 3, which is the equivalent to N, plus 25Q is equal to 225. Okay, so I don't have enough room here. We'll go ahead and let's just bring that same equation over here. And we'd have 5 times Q plus 3 plus 25Q is equal to 225. And we're going to go ahead and just solve that for Q. And actually, I guess in this particular problem, they didn't really ask us about N. This is the most important thing. But we'll go ahead and find the number of nickels. That'll be easy enough at the end of the problem as well. But let's find Q here. So we're going to get 5Q. I'm distributing, and 5 times 3 is 15, plus 25Q is equal to 225. I'm going to add 5Q and 25Q and get 30Q. I'm going to subtract 15 from both sides. And now I have 30Q equals 210. And I need to divide by 30 on both sides there. Ran out of room, but I would get Q is equal to 7. If I went and divided both sides by 30, I'd get Q is equal to 7 quarters. All right, and if I have 7 quarters, I should be able to go over here where I have Q plus 3 is equal to N, and that would mean that I ended up with, if N is equal to Q plus 3, then N is equal to 7 plus 3, or 10 nickels. I have 7 quarters and 10 nickels. Okay, and there's our solution.